Okay, how many are done here in class? 1, 2, 3, you? Okay, so let's try and do this together. So we have this equation. There's going to be how many terms that we collect up? It's going to be 7, right? 7 different terms that we collect up. 2, 4, 6, 8. 8 terms. Oh, coefficient. Constant coefficient, 8, okay? So what we're trying to do is we're trying to figure out kind of the blending matrix, the MBE, that goes in here. This first column, okay, that we write down here is going to come from 1 minus u to what power? What did it do when we were doing cubic? 1 minus u cubed. So we're doing 7th order. So this column is going to come from the coefficients of 1 minus u to the 7th. What is the next column going to come from? Well, it's going to be from our u, 1 minus u to the 6th power, and it's going to have some coefficient in front of it. What is the next column going to come from? The u squared, 1 minus u to the 5th. All of the powers have to add up to 7. And there's going to be a coefficient there. The next column is going to come from u cubed, 1 minus u to the 4th. Coefficient out front. The next one is going to be u to the 4th. 1 minus u to the 3rd, and a coefficient. The next one is going to be u to the 5th, 1 minus u squared, coefficient. U to the 6th, 1 minus u, coefficient. The last one is going to be u to the 7th. Add some coefficient out to the front of that. Right? What are all the magic coefficients that go in front of these things? Well, it's this bottom row. So this has a 1, a 7, a 21, a 35, a 35, 21, a 7, and a 1. So we can just write down the coefficients of this column from where? From this bottom row. Is it going to change? No, because the coefficient is 1. So we can just write down 1, 7, 21, 35, 35, 21, 7, and 1. And what do we have to do? Alternate signs. Minus, 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 minus. What do we do across the bottom row? Write those same numbers. Why do we write those same numbers across the bottom? Where does it come from? Well, it's the last term of every one of these things expanded, and the last term of every one of those things expanded is multiplied times what? 1. And so we end up getting the same thing, 7, 20, 21, 35, 35, 21, 7, and 1. We start with this sign and we just alternate the signs going across. And what do we do down the diagonal? The same thing, but all positive. So 7, 21, 35, 35, 21, up too high, up way too high, 35, 21, 7, and 1. Is everybody with me so far? Okay. How do I get the rest of the numbers in column 2? Where do they come from? I take the 7, which is the coefficient of that, and it's right here, if I want to think this way, and I multiply it times the row just above it. So 7 times 1 is 7, 7 times 6 is 42, 7 times 15 is 95, 105, thank you, 105. 7 times that, 140, 105, 42. And what do I have to do? Alternate signs. So minus 42, minus 140, minus 42. How do I get the next one? So I look at the coefficient, which is 21, and I take 21 and I multiply it times, this is now the 5th order curve. So I get 21, and that's going to be, what, 105? And the next one is going to be 210, 210, 105. What do I do? Alternate signs. And so on and so forth. And then your thing, and zeros. And the thing about the computer is the computer can do this really fast. Now the CAD system, if you played with it, how high of an order can you set for any kind of curve that you define? On some of the CAD systems, you can set it as high as like a 90th order curve. Okay. Some limit it to about a 13th order curve. Okay. In real life, what is the highest order curve that industry really works with? They will work with 5th order curves. They prefer to work with 4th order curves. And they really love it when they can work with 3rd order curves, cubic curves. Okay. But if you think about a cubic spline controlled by 4 points, can you do a complete airfoil with a single Bezier curve? Could you do a single airfoil with a 4th order Bezier curve? Or a 5th order Bezier curve? You may have to get up to like a 9th order Bezier curve if you want to define a reasonable airfoil. Industry, the jet engine industry, will usually use 120 points to define the cross-section of an airfoil. So if you were trying to do that with a Bezier curve, what would you have to do? You would have to have a 119th order curve, right? To handle 120 points. So Bezier doesn't allow you to do much with a complete complex curve, and they use the Bezier as the underlying kind of mathematics for coming up with B-splines and coming up with NURBS, because you can keep the order low and you can attach all of these segments together into a single Bezier or B-spline with what is called a knot vector. So the knot vector is what glues a bunch of these third order or fourth order curves together to be able to fit through 120 points and do it without a lot of wiggles. Because if you had a 119th order Bezier, it's going to potentially have how many roots, how many zeros is it going to have crossing the axis? 119 of them. And so that's a lot of wiggles to try and control. And so industry says, this makes no sense, it doesn't work. So let's figure out how to glue them together. And a knot vector, which you'll read in the book about, we'll talk about knot vectors. Knot vectors are the magic that allow you to kind of glue Beziers together and keep the order of the curve low. And you want lower order curve because it is smoother by definition. Fewer times it's going to cross the zero, the axis. Are we back to showing slides? I think so. And we are 2 minutes away from being out of time. Please, between now and Tuesday, look at the spline portion of this. The spline portion is where we try and determine coefficients from points that are on the curve. So we talked in at the beginning of the class, we talked about being able to give points that are on the curve. We talked about giving points that control the curve as a net, okay? So what we just went through was the control net. What the spline talks about is points on the curve, okay? So we need to kind of understand both of these because that's what the CAD system allows us to do. It allows us to put points as control points. It also allows us to put points actually on the curve, and the curve just magically goes nicely through those points. So look at that. We'll pick up on Tuesday with our discussion of splines, and we will begin to transition over to surfaces. So catch up, do the reading on curves, and then move into chapter 7, which begins talking about surfaces, focused primarily on the section that talks about Bezier surfaces. Okay, there's lots of surfaces, focus mostly on the section dealing with Bezier surfaces.